The next concept I want to discuss is Bernoulli's principle. Now, Bernoulli's principle can be a bit complicated, but when we break it down into its simplest form, essentially all it is just a relationship between fast and slow moving particles. Now, when we think of Bernoulli's principle, we often think of airplanes or flying objects of some kind. Because that's just kind of the easiest way to apply this principle. We think the fast-moving particles, which if you think of an airplane, are the ones that will be traveling over the top side of the wings, those have a low pressure, while the slower-moving particles, which would be traveling underneath the wing of an airplane, they are going to be higher pressure. The higher pressure molecules are going to create lift and therefore keep the plane up. Now, an example that I found that is not related to flying machines of any kind is just simply a draft in a room. So we've all at some point in time felt a draft come through a room. How this works is if I'm in a room and this room is particularly hot, but it is cooler outside that door and is cooler outside the far window. If I want to cool it down in this room, if I just open up this door behind me, the cool air will rush in very quickly. But because it is a fast-moving particle, those are fast-moving particles, they're going to have a low pressure. Conversely, if I were just to open up the far window over there, the hot air is going to rush out very quickly, but it will now be a low pressure in the room. So the temperature will not drastically change. In order for me to lower the temperature in here and truly be able to feel it, I would need to open both this door and the far window. That is going to create a slow-moving atmosphere where the cool air is slowly filtering in as the hot air slowly filters out that direction, which will be higher pressure and therefore will cool the room down.